Going back to our unit circle, talking about our 0 degree or our 0 radian angle, our 90 degree or pi over 2, the point, let me get rid of that 0. The points at the end of this are 1, 0, 0, 1, negative 1, 0, 0, negative 1. And what was the shortcut for coming up with the tangent? What was the shortcut for coming up with tangent when you have the points? Y divided by x, right? Sine divided by cosine. So the y coordinate divided by the x coordinate. So the 4 main ones that we can get from just these points is at 0. At a 0 radian angle, the tangent is 0 divided by 1, which is 0. So we have the point 0, 0. And then at a pi over 2 radian measure, y over x, 1 divided by 0 is undefined. So when something is undefined, we get an asymptote. And I'm actually going to go backwards this way to negative pi over 2, because at negative pi over 2, you also get negative 1 divided by a 0, and therefore an undefined. So at negative pi over 2, we also have that. Now, if you are just passing a 0 radian measure, we can even talk degrees if you want. If we get to just past a 0 degree, what is the ratio of your opposite to your adjacent? Is it big or small? Fairly small, but positive, right? A positive over a positive. As you move through the first quadrant, what happens to the ratio of your opposite over your adjacent? Is it growing or shrinking? Growing, right? It was small, positive at first as we entered our first quadrant, because we all agree this is Q1 from 0 to pi over 2. That's quadrant 1. It's small at first, but it's getting bigger. And then the question is, how big? So as this hypotenuse sort of approaches being on top of the y-axis, your opposite side is approaching what? As we move around the unit circle? 1. Your adjacent side is approaching 0. So think about a triangle where your opposite is like 0.99999 and your adjacent is 0.00001. You've got a pretty large number being divided by something that's getting infinitely small towards 0, which means what are you approaching? If you take, let's, for lack of a better number, we'll take 1 and divide 1 by a teeny, 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 tiny number. What is that approaching? Infinity. It's like 1 being divided by 1/100. Goes in 100 times. If that was, let's say, 1/100. But when this gets even smaller and it gets to be 1/1000, right? Your opposite side of 1 divided by 1/1000 is 1,000. And then this gets even smaller and is 1/1,000,000th. So the opposite side that's approaching 1 divided by 1/1,000,000th is 1,000,000. Do we follow? So as this gets infinitely small towards 0, this is the opposite over that teeny tiny number is approaching infinity. And that's where this comes from. Just like we've seen with asymptote behavior before, as you approach an asymptote, you have to be approaching either positive infinity or negative infinity. And I know you know what the tangent graph looks like, so I know you know what happens over here, but let's look at what happens if I go backwards into the fourth quadrant from an opposite over adjacent standpoint. Let's pretend my terminal ray is getting very close to the y-axis, and I drop my triangle. My opposite side is approaching what length? If this is my angle, my opposite side is approaching what length as the angle is moving open? -1. And my adjacent side is, again, getting infinitely close to 0. So you're essentially going to have -1 eventually divided by 1/1,000,000. And then therefore we get -infinity. Yes? And as we go into that fourth quadrant, that's approaching -infinity. Do you follow? From pi over 2 to pi, what quadrant are we in? Q2. Okay. We know that right at pi, what's y over x? 0. Okay. So what's happening in quadrant 2? If I just draw a random terminal ray, my opposite side is positive, my adjacent side is negative, right? Agree? Left, negative, that's positive. If I get as close to pi over 2 with that terminal ray, what is my, as my terminal ray gets as close to pi over 2, so on our graph we're getting as close to this asymptote as we can, what's happening to the opposite side? What's it approaching as my terminal ray approaches pi over 2? No, what is this opposite side approaching? 1, +1. And what's this side approaching? 0, coming from the negative, a negative value though, right? Like -0.01 or -0.001. So the opposite side, which is essentially 1, divided by a teeny tiny negative, is also going to produce a -infinity. Which is why when you're getting towards pi over 2, your graph goes towards -infinity. And then we enter quadrant 3. And I know you know what's going to happen, but when you are in quadrant 3 and approaching the 3 pi over 2, which we know is y divided by x, -1 divided by 0, it's undefined at 3 pi over 2. We explore what happens as our angle gets closer and closer to 3 pi over 2. So if I were to sketch a terminal ray, kind of as close to 3 pi over 2 as I can and still see a triangle, what's my opposite side approaching? -1. What's my adjacent side approaching? 0, but a negative number, right? So like something like -0.00001. And that goes in, and that number is going to be approaching +infinity. Yes? It's going to go in a positive number of times and a lot of times. So this goes towards +infinity. And so you get this repetitive, because we'll be in quadrant 4 again, like we were over here, right? This was quadrant 4, opening our terminal array in the negative direction. This is going to be quadrant 4 again, and then this is going to just continue over and over again. Okay? So when we talk about tangent graphs, couple things. Our period is different. Our period is what? Just pi. From -pi over 2 to +pi over 2, that's a distance of pi. And then that cycle repeats. Okay? Very importantly, we have asymptotes. How would you describe where our asymptotes are? Well, technically this is 2 pi over 2. So not every pi over 2 units. It's almost like every other, right? Every 1 pi over 2, but not at 2 pi over 2. 3 pi over 2, but not at 4 pi over 2. So how would you, odd pi over 2 is how you would kind of loosely speak it. But if you wanted to write it, there it's at x equals k pi over 2, where k is a what? I'm going to go with odd integer, just to make sure we only state that, which I know is what you meant, but we'll go with integer. So your asymptotes are at x equals k pi over 2, where k is an odd integer. K could be a positive 1, positive 3, positive 5, negative 1, negative 3, negative 5. Does this make sense? Okay? So these are the key features of the tangent parent graph. Okay? We also have x-intercepts. We could talk about that. Not as frequently talked about as the asymptotes, but the x-intercepts are at x equals k pi over 2, where k is an, right. So your 0 pi over 2, your 2 pi over 2, your 4 pi over 2, and so on. Well, that's a silly way of writing it then. Because where are these x-intercepts actually at if k has to be an even number? 0 pi over 2, 2 pi over 2, multiples of pi, just plain pi, right? 0 pi over 2, 2 pi over 2 is just 1 pi, 2 pi, 3 pi. All of your x-intercepts are actually going to occur at just k pi, where k is an integer, any integer. Whole number pi's. Good? Let's take one moment to go on the website.